Have you ever really stopped to think about how your devices talk to each other when they're right there in the same room? Well, today we're going to pull back the curtain on the network's local delivery service. It's a fundamental piece of the puzzle called the data link layer, and we are going to dive right in.
Seriously, think about it for a second. You hit print on your laptop, and somehow, that document zips across your Wi-Fi and lands on your printer, not your smart TV or your roommate's phone. You think it's magic, right? Well, it's not. It's actually a very specific, very clever system designed to solve exactly this problem.
All right, here's our game plan. We're going to start with the big picture of this whole local delivery idea. Then we'll dig into the specific jobs this layer has. After that, we'll get to know its unique addressing system. It's super important. We'll see how it packages up data for travel, and finally, we'll wrap it all up with a really simple analogy that'll make everything click into place.
Okay, so let's talk about this invisible workhorse. It's the unsung hero that's constantly buzzing around in the background, making sure all the devices in your home or office can actually find each other.
And its name is the data link layer. You might also hear it called Layer 2. Its entire reason for existing, its whole job, is to manage the communication between devices that are on the exact same local network. Not across the world, just right there, in the same digital room. So what does it actually do all day? Well, it's not just one thing. It's really a handful of absolutely crucial, highly structured tasks that make sure all that local chatter happens without a hitch. And here they are, the 4 big jobs. First up is framing. This is so cool. It takes the raw, chaotic stream of ones and zeros from the physical hardware and organizes it into neat, structured packages called frames. Then there's MAC addressing, which we're going to talk a lot more about. Next, error detection. It does a quick check using something called a CRC to make sure the data didn't get scrambled on its journey. And finally, flow control, which basically means it makes sure the sending device doesn't talk too fast and overwhelm the receiving one. It's just good manners, really. Now, to get all this done, the layer is actually split into 2 halves. You've got the LLC, or logical link control, which is kind of like the diplomat that talks to the layer above it, the network layer. And then you have the MAC, or media access control sublayer. This is the one we're really interested in today. It's the part that handles all the physical addressing. And that brings us to the absolute heart of how this all works. See, every single network-capable device you own, your phone, your laptop, your printer, has a permanent, totally unique digital fingerprint. It looks something just like this. It's a 48-bit number, usually written out as 6 pairs of letters and numbers with colons in between. Now, this isn't just a random code. It is a globally unique address. No 2 devices in the world should have the same one. And this fingerprint has a name, the Media Access Control Address, or what we all call a MAC address. The wildest part? It's literally burned into the hardware of your device's network card by the manufacturer. It's not software. It's a permanent part of its physical identity. This is probably the best way to understand the difference between a MAC address and an IP address. Think of an IP address like your current mailing address. It's for getting things sent to you from anywhere in the world, and it changes if you move, like when you take your laptop to a coffee shop. But a MAC address, that's like your name on your birth certificate. It's permanent, it doesn't change, and it's really just used for identification locally within your own building. Okay, so now that we get the address, let's look at how the data link layer actually uses it. It's all about taking that raw data and giving it a very specific structure, getting it ready for its short trip across the local network. And this whole process is called framing. Instead of just a messy jumble of electrical signals, the data link layer creates these neat, tidy packages. It's basically like taking a bunch of notes scribbled on a napkin and putting them into a proper envelope with a clear to and from address. And this is what that envelope, the data frame, looks like. It's got a very clear structure. First, you've got the destination MAC address. Where is this going locally? Then the source MAC address. Who sent it? The ether type field is interesting. It tells the receiver what's inside the package, like an IP packet. Then you have the payload. That's the actual data, the message you wanted to send. And tacked on at the very end is that CRC, the error checking code, just to make sure the message arrived perfectly intact. All right. I know this has been a bit technical, so let's use a simple, real-world analogy to make all of these concepts really stick. Just imagine for a second that you're mailing a physical letter. Getting it from your desk to your friend's desk isn't a single step, right? There are layers to it. And believe it or not, computer networks work in a very, very similar way. This table lays it out perfectly. The network layer, which uses those IP addresses we talked about, is like the main city postal service. Its only job is to get that letter to the right building address in the entire city. But the data link layer, using the MAC address, is like the mailman who works inside that specific apartment building. Their job is to take it from the mailroom and get it to the exact right apartment door.
So that IP address on the envelope is what gets your data across the vast global internet all the way to the correct local network, the right building.
But once it arrives in that building's mailroom, which is basically your router, that's when the data link layer clocks in. It looks at the MAC address, the apartment number, and makes that final hyper-specific delivery to your laptop, your printer, or your phone.
And that, right there, is the most important thing to remember. Without the data link layer and its permanent MAC addresses, data could get to the right network, sure, but it would just be lost in the mailroom. It's the expert that handles that last, critical, detail-oriented step of local delivery. So this MAC address, this permanent hardware identifier, is absolutely fantastic for making our local networks work so smoothly. But here's a thought. It also means that this digital fingerprint is broadcast to any network you connect to. It brings up a really interesting and important question. What are the privacy implications when a tool designed for local delivery could also potentially be used to track your movements from one network to another? Something to think about.